Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on Graphical Inequalities. If you need an extra help on Graphical Inequalities, if you go to Corbettmaths and go to the Videos and Worksheets section and scroll down to video numbers 180, 181 and 182, there's dedicated video tutorials on Graphical Inequalities. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's look at our first question, question number 1. So question number 1 says, on the grid, clearly indicate the region that satisfies these inequalities. And we've got x is bigger than or equal to 3, y is bigger than or equal to 1, and x plus y is less than or equal to 5. Now, actually, just before I carry on, I want to mention a couple of things. One is, here, if we have a look at these inequalities, we've got bigger than or equal to and less than or equal to. Now, some exam boards will just use these types of inequalities where they're bigger than or equal to and less than or equal to, and they avoid using the bigger than and less than inequalities. In this booklet, I do include both. The reason is obviously some exam boards do include both, and it's important that if you're doing those over exam boards, you know how to approach them. So I'll talk about those bigger than and less than inequalities when we get to them. And the second thing is, whenever it comes to indicating the region, some teachers and some textbooks and so on use slightly different approaches to whenever it comes to indicating that region. In terms of the approach that I use, I'll be using an approach to show you how to indicate that region, and to me it makes sense, and that will get you full marks in the GCSE exams. But it doesn't necessarily mean that if your teacher uses a slightly different way that their way is wrong. If it's indicating the same region, it's going to get full marks anyway. Okay, so I just want to mention those two things in terms of the inequality signs that are used by the questions and also how the region is indicated. Okay, so here we've got our grid, and we need to indicate on this grid the region that satisfies all three of these inequalities. So our first inequality is x is bigger than or equal to 3. So on the grid, it'd be all the points where the x coordinate of the point is bigger than or equal to 3. So for instance, 5 across 1 up, that would work because the x coordinate is 5, it's bigger than or equal to 3. 4 across 6 up, the x coordinate of 4 is bigger than or equal to 3. 3, 4, because it's 3 across 4 up, the x coordinate is bigger than or equal to 3. But this point here, 2, 1 wouldn't work because the x coordinate is 2, it's only 2 along the corridor. So in terms of the points that would satisfy that, it'd be all these points over here, where the x coordinate is bigger than or equal to 3. So what I like to do is to show that region, first of all I start by drawing the graph. Instead of x is bigger than or equal to 3, I'm going to draw the graph of x equals 3. I'm going to draw that graph on the grid to begin with, x equals 3. I'm also going to draw the graph of y equals 1 and x plus y equals 5. I draw those to begin with, and then I figure out which side of that line will satisfy the inequality. So let's start off with this one here, x is equal to 3. So x is equal to 3, it's a vertical line that passes through 3 on the x-axis, because for instance 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, 4.5 even, all those points have got an x coordinate that's equal to 3. So let's draw that line. So that's the graph of x equals 3. Now I just want to mention there I've done a solid line because it was bigger than or equal to 3. If it was just bigger than 3 or less than 3, I would have done a dashed line there instead of a solid line. But because it was bigger than or equal to 3, I've done a solid line there. And then in terms of where the points would be that would satisfy that inequality, where x is bigger than or equal to 3, all the points on the line would satisfy it because that's equal to 3. All the points on that line have got an x coordinate that's equal to 3. And all the points on the right hand side would satisfy it as well because 4 across 2 up, as I said, that point there has got an x coordinate that's bigger than 3. So all the points that are either on the line or to the right of the line would satisfy the inequality. I'm just going to do some lines on the left hand side to show that we're rejecting that region. So I'm just going to do some lines like this. I could do lines going the whole way across here, but I'm just doing this as just a bit of a reminder to myself because we're going to have 3 lines drawn on this grid. And when we've got all 3 lines drawn on it, we might forget which side we're accepting and which side we're rejecting. So we're rejecting everything to the left of that line. And I've just done those little dashes just to remind myself. You don't necessarily need to do that. If you look at some textbooks, it might even shade to the right, but I think it's really misleading when you're trying to find which bit's shaded in 3 times. I find it just a little bit easier to shade the bit that we're rejecting, like so. So we've dealt with this inequality, x is bigger than or equal to 3. That's all the points that are on the line and to the right of the line. Okay, now, y is bigger than or equal to 1. So I'm going to draw the graph of y equals 1. So that's where the line where all the points, the y coordinate is equal to 1, such as 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 5.11 and so on. So that'll be that horizontal line passing through the y-axis at 1. So let's draw that line. So that's the line y equals 1. Now we want to find the region that would satisfy the inequality. where all the y coordinates are bigger than or equal to 1. So all the points on the line would work because there all the points have got a y coordinate of 1, and all the points above that horizontal line would work. So for instance up here, if I was to choose this point here, 4, 6, the y coordinate is 6, it's bigger than or equal to 1. But the points below the line wouldn't work. So for instance here, 4, 0.5, that wouldn't work because the y coordinate isn't bigger than or equal to 1. So we're going to reject below that line. So we want to accept above it, so I'm just going to do little dashes below to show we're rejecting below that line. So we're rejecting below the line. So far, in terms of the points that would satisfy both of these two inequalities, it would be all of these points here. All the points in this region here would satisfy both of those inequalities. Okay, and then finally, we've got x plus y is less than or equal to 5. So we're going to draw the graph of x plus y equals 5 to begin with, and then what we're going to do is figure out what side of that line we're going to accept and what side of that line we're going to reject. Now, in terms of x plus y is equal to 5, there's a bit of a shortcut. If you've got x plus y, where it's just x plus y equals a number, so x plus y is equal to 5, it's going to be a straight line that joins that number on the x-axis and the y-axis. So here, if I was to put a point here at 5 and a point down here at 5 down there and join them up, that'll be the line of x plus y equals 5. Because if you look at it, you've got the point 0, 5. If you add them together, you get 5. 1, 4, well 1 plus 4 is equal to 5. 2, 3, 2 plus 3 is equal to 5, and so on. So that diagonal line would be the line of x plus y equals 5. But if we didn't know that little shortcut, what we could do is do a little xy table, so x and y, and then our xy table, and choose some points 0, 1, and 2. So if the x coordinates equal to 0, 0 plus something is equal to 5, well y would have to be equal to 5, so 0, 5 is that point there. If x is equal to 1, 1 plus something is equal to 5, well, that would be 4, so 1 across 4 up would be there. 2 across 3 up would be there. So we've now got these points there in that diagonal line. So that's, if we draw a line through it, that'll be the line of x plus y equals 5. So that's now the line of x plus y equals 5. And in terms of the region that would satisfy that inequality, all the points on the line would work, because remember that x plus y is less than or equal to 5. So because it's got the equal to part, all the points on the line would work. Now we just need to decide what region we're going to accept and which one we're going to reject. So in terms of this diagonal line, are we going to be accepting the region up here, or are we going to be accepting the region down here? Now to do that, what I do is I choose a point that's not on the line. So a point that's not on the line is clearly the origin. The origin here, the point 0, 0, is clearly not on that line, x plus y equals 5. And I know for the origin, we've got the x coordinate is 0 and the y coordinate is 0. And if I substitute in 0 and 0 for the values of x and y into the inequality, which is x plus y is less than or equal to 5, if I substitute those points in, it will either find that it works for the inequality or it won't work for the inequality. If these two numbers, when we substitute it in, it works for the inequality, then we know that region we're going to accept, and we want the points that are below that diagonal line. If we substitute in 0 and 0 into this inequality and we find that it doesn't work, that means we're going to be rejecting this side and we'll be accepting the bit above the diagonal line. So let's substitute in 0 and 0. So the x coordinate is 0, so we're going to get 0 plus the y coordinate is 0, and that hopefully will be less than or equal to 5. 0 plus 0 is 0, and that is less than or equal to 5. 0 is less than 5, so that does work. So that means the origin is in the region that we want to accept. So we're going to accept everything below that diagonal line. So it means we're going to reject everything above it. And I do my little shading, my little lines just above to show we're rejecting everything up here. So all the points up there we're rejecting. And let's just check this point here, 5, 6. If you substitute in 5 and 6 into here, you get that's equal to 11, and 11 isn't less than or equal to 5. So all the points up here wouldn't work. So if we have a look here, we've now got, if we go back to that original, x is bigger than or equal to 3. We're accepting everything to the right here. For the inequality, y is bigger than or equal to 1. We're accepting everything above that line, so we then had that region there. And then we've got x plus y is less than or equal to 5. So then we're left with this region here. So this is the region, and I'm going to indicate it with a little r. Now the question sometimes says how to indicate the region. They might say to shade it in, and then we'd shade it in. Sometimes they might say indicate it with the letter r, and so on. And that's it. So all the points that are inside that region, or even on the lines going around the perimeter of that little triangle, would also work. So for instance, the point here, 3, 2. Here your x coordinate is 3, so it's bigger than or equal to 3. 2, well 2's for the height, 2's bigger than or equal to 1. And 3 plus 2 is less than or equal to 5. So that point would work. So all the points that are in that region or on the outside that region would work as well, because remember all of them had that equal to part. And that's it. We've done that question. Okay, let's look at our next question, question number 2. Okay, so question number 2, we've got this grid and we've got some lines that have been drawn for us. We've got x plus y equals 3. And again, that little shortcut works. Remember, it's x plus y, so it's just x plus y, and it equals 3. So it crosses the x-axis at 3 and it crosses the y-axis at 3. It's just a little bit of a shortcut that you might get to learn. And here we've got the line y equals 2x, so that diagonal line. And the question says, draw another line on the grid and label the region that satisfies the inequalities. So we've got x plus y is less than or equal to 3, y is less than or equal to 2x, and y is bigger than or equal to negative 3. Now, if we have a look here, the first two look familiar. If we go back up, x plus y equals 3, well, it's a bit like that. If I wanted to draw the region on the grid that satisfies that inequality, I draw x plus y equals 3. And then I figure out what side of the line would satisfy the inequality. Likewise, here I would draw y equals 2x, and here I would draw y equals minus 3. And these first two have been drawn for us. If we go back up, we've got x plus y equals 3 and y equals 2x there. So that's fantastic. So the last one we need to draw is this one, our y equals minus 3, or y equals negative 3 on the grid. And then we just need to shade the region, label the region that satisfies all of those inequalities in black there. Okay, so let's start off by drawing the last line, y equals negative 3. So it's going to be a horizontal line that passes through negative 3 on the y-axis, because remember, it's all the points with a y-coordinate of negative 3. So 4, negative 3, 5, negative 3, 1, negative 3, and so on. So it's going to be a horizontal line that passes through negative 3 on the y-axis, so something like that. Now we need to find the region that satisfies all of the inequalities. Now I'm going to start off with this one here, this one we've just drawn. We had y is bigger than or equal to negative 3. So the heights are bigger than or equal to negative 3. So equal to, so it could be all the points on the line. That's why I've done a solid line there. I haven't done a dashed line, I've done a solid line because I had the equal to part. Then it says bigger than negative 3, so it's going to be all the points above the line. So all the points below the line wouldn't work for that inequality. So for instance, this point here, 1, negative 4. The y-coordinate is negative 4, and negative 4 is not bigger than negative 3. So all the points below that line wouldn't work. All the points on or above the line, so the origin, for instance, would work because 0 is bigger than negative 3. So what I'm going to do is I'm going to do little dashes like this just below the line to show we're rejecting below that line. I find whenever you've got those 3 lines on, sometimes even you've got 4 lines on that grid, it can be hard sometimes to remember which bit you're accepting, which bit you're rejecting. So I just use those as a bit of a aide-memoire just to remind myself. Okay. Now our next one, y is less than or equal to 2x. So it's less than or equal to 2x. So we've drawn the line y equals 2x, or it's drawn for us. It's that diagonal line there. And we want to find out which region on the grid is going to satisfy the inequality of y is less than or equal to 2x, y is less than or equal to 2x. So which region of that graph, the bit up here or the bit down here, will satisfy y is less than or equal to 2x. Now, whenever it's a diagonal line, what I tend to do is I tend to choose a point that's not on the line. So I'm not going to choose the origin this time because the origin's on the line, and we know that because it's less than or equal to, that will satisfy because it's on the line. 0 is less than or equal to 2 times 0. 0 is equal to 0, so that would work there. So I'm going to choose a point that's not on the line. So a point that's not on the line is this point here, the point 1, 1. The point 1, 1 is not on the line, so the point 1, 1. It's got an x-coordinate of 1 and a y-coordinate of 1. And let's substitute them into this inequality and see does it work or does it not work. So y, so that's 1. And then we've got less than or equal to 2 times x. So 2 times 1 would be 2. And 1 is less than or equal to 2? Well, yeah, 1 is less than 2. So that means the point 1, 1 is on the side of the region that we're going to accept. So that means that we want to accept this region down here, but we want to reject everything above that diagonal line. So let's just reject everything above that diagonal line. And all the points below that diagonal line will work, and all the points down this way would work, and all the points up there would not work. And let's just check this point here, 6, 0. So the x-coordinate is 6 and the y-coordinate is 0. 0 is less than 2 times 6. That's 12. 0 is less than 12. Yeah, that works. And if you choose a point up here somewhere, it wouldn't work. Okay, so we now know we've got this region here somewhere, but we obviously need to consider this other diagonal line here, x plus y equals 3, and we need to look at the inequality, which is x plus y. I'm just going to write over here, x plus y is less than or equal to 3. And we need to figure out, are we going to be accepting the region above this diagonal line or accepting the region below the diagonal line, like so. Okay, so let's choose a point that's not on that diagonal line there. Now remember, all the points on the diagonal line would satisfy because it's x plus y is less than or equal to 3, so all the points on the line would work. Okay, so I'm going to choose the origin. The origin here, it's not on the line, so it's just any point that's not on the line, and that'll tell me whether this side is going to be accepted or rejected. So in terms of the origin, that's the point 0, 0. It's got an x-coordinate of 0 and a y-coordinate of 0. So we'll have 0 plus 0 is less than or equal to 3. 0 plus 0 is less than or equal to 3. And 0 plus 0 is 0, so you get 0 is less than or equal to 3. And 0 is less than 3. So that means that that is on the side that's being accepted. And that means we're going to reject the region above that diagonal line. So we're going to reject everything up here. This point, for instance, 0, 5. If you had the point 0, 5, you'd end up with 5 is less than or equal to 3. No, that wouldn't work. So that means you'd be rejecting this region. So we're going to be rejecting everything above that diagonal line. Remember, I just did little dashes for the region that we're rejecting. So that line, that diagonal line, we're just doing little dashes above it. And as you can see here, we're left with this region here. We've got this triangular region where all the points in that region or on the perimeter of that little triangle would work. And that's it. So I'm going to label that with an R. And that's it, because it said to show that region, it just said to label it. So I'm going to label it with an R, that region there. Okay, let's look at our next question, question number 3. Okay, let's have a look at our next question, question number 3. So question number 3 says, on the grid, clearly indicate the region that satisfies these inequalities. And we've got y is less than x, y is bigger than or equal to 1, and x plus y is less than or equal to 4. Okay, so what I'm going to do is I'm going to draw the graphs of y equals x, y equals 1, and x plus y equals 4. And then once we draw those lines, we can then figure out what sides of those lines would represent or would satisfy those inequalities. Okay, so I'm going to start off with these two. I'm going to start off with y is bigger than or equal to 1. So I'm going to draw the line of y equals 1. So the line of y equals 1 would look something like this. It'd be a horizontal line passing through 1 on the y-axis. So it would look like that. And the reason it would look like that is all those points on that line have got a y coordinate of 1. So 0, 1, 0.51, 1, 1, 1.51, 1.71, 3, 1, and so on. So all those points on that line have got a y coordinate of 1. Now the region that would satisfy that would be where it's bigger than or equal to 1. Y is bigger than or equal to 1. So all the points on the line would satisfy that inequality, but all the points above the line would satisfy it as well. So for instance, 1, 6, the y coordinate is 6. It's bigger than or equal to 1. So we're going to reject below the line. So we're going to reject below that line. And I'm just going to do these little dashes to show that's the section we're rejecting. All the points below that line would not work for that inequality. Okay, our next one, x plus y is less than or equal to 4. So we're going to draw the line of x plus y equals 4. And again, we could use the shortcut. Remember, if it's x plus y equals a number, you just go to that number on the x-axis and the y-axis and join them up. So it'd be 4 there on the y-axis and 4 there on the x-axis, and then join them up, and then that'll be the line x plus y equals 4. Alternatively, we could do an xy table. So x and y, 0, 1, 2. If x is equal to 0, well, 0 plus y equals 4, so y would have to be equal to 4. If x is equal to 1, 1 plus y is equal to 4, so y would have to be 3. And if x plus y is equal to 4, if x is equal to 2, y would be equal to 2. So let's plot those points. 0, 4 would be there. 1, 3, 1 across 3 up would be there. 2, 2 would be there. So we've got those points. Now let's get our ruler and pencil and draw a nice straight line through them. So a nice straight line joining from there down to there. Okay, so that's the line x plus y equals 4. Now we need to figure out what side of that line would satisfy the inequality. So let's go to the inequality. X plus y is less than or equal to 4. So let's choose a point that's not on that line. So we're going to choose the origin. So the origin there, obviously that's the point 0, 0. So 0, 0. We've got an x coordinate of 0 and a y coordinate of 0. Well, the x coordinate is 0 and the y coordinate is 0. So we'd have 0 plus 0 is less than or equal to 4, and 0 is less than 4, so that would work. So that means that that's the side of the line, so below the line there would be the region that we wanted. All those points below the line would satisfy the inequality, and on the line as well, because it was less than or equal to 4. But all the points above that diagonal line would not satisfy the inequality. If we chose this point 1, 6, if you do 1 plus 6, that's equal to 7, so that wouldn't work. So let's reject above the line, so like this. Okay, so we've done this inequality, y is bigger than or equal to 4. We've done this inequality, x plus y is less than or equal to 4. Now let's have a look at this one. Y is less than x. Now this is our first inequality where it's just a less than, it's not less than or equal to. So whenever it's a less than or greater than, what we do is we draw the graph of y equals x, but instead of doing a solid line, we do a dashed line because it's y is less than x. It can't actually be on the line. So let's draw the graph of y equals x. Now you may know this graph already. It's the graph that goes through the origin and passes through the points 1, 1, 2, 2, 3, 3, and so on. Or we could do a little xy table, x and y. If x is equal to 0, well, y is equal to x, so y would be 0. If x is equal to 1, y would be 1. And if x is equal to 2, y would be equal to 2 because they're equal to each other. So let's plot those points. 0, 0, 1, 1, 2, 2. So we've got those points there, 1, 2, 3. Now we're drawing the graph y equals x, but if we have a look at the inequality, it's y is less than x. So it can't actually be the points on the line. Now, as I mentioned, some exam boards avoid these type of inequalities, but some do include them. So it's important we know how to approach them as well if you are doing those exam boards. So here we've got y is less than x. So whenever we draw this line, we're going to do a dashed line that goes through them. So let's do that. So that's the line y equals x, but I've done a broken line because obviously the points can't be on the line itself. So now we need to decide what side of the line we're going to accept and what side of the line we're going to reject. So I'm going to choose a point above the line here. So I'm going to choose this point here, the point 1, 8. So the point 1, 8. It's got an x coordinate of 1 and a y coordinate of 8. And it can be any point that's not on the line. It could be above the line or below the line. I've just chosen that one there, 1, 8, because it's a point above the line. So we've got the x coordinate is equal to 1 and the y coordinate is equal to 8. So here we've got the inequality, y is less than x. And we want to see if this point would satisfy it. So y is 8, and then that is less than x, which is 1. And 8 is less than 1? No, it's not. So that point isn't in the region that we're going to accept. We're going to reject this region. So we're going to reject all the points above that diagonal line, and we're going to accept all the points below it. So we want all the points below that diagonal line. So let's reject above it. So I'm going to do little dashes above that little dotted line there. So that's going to show us where we're rejecting. And if you have a look here, we've got this region here. This region here, all the points inside of that region would satisfy the inequality. And all the points on this solid line and this solid line would also satisfy the inequality, but this line here, obviously it's a dashed line, so the points on that line wouldn't satisfy. But all the points inside of that region would satisfy. We've been asked to clearly indicate that region, so I'm going to do a little R there, so that's the region there. And that's it. Okay, let's look at our next question, question number 4. Okay, so question number 4, we've got these two lines here, and we've got this region shaded in and marked with an R there. And the question says, tick the pair of inequalities that describe the shaded region. So we want to describe this shaded region. This is the region R that they want us to describe. We need to pick which of the inequalities would represent that region. And let's look at our options. X is bigger than or equal to -3, and y is bigger than or equal to 4. X is bigger than or equal to -3 and y is less than or equal to 4. X is less than or equal to -3 and y is bigger than or equal to 4. And x is less than or equal to -3 and y is less than or equal to 4. Okay, so let's have a look at the lines. So the lines, this is a horizontal line that passes through 4 on the y-axis. So this line is the line y equals 4. And this line here, it's a vertical line that passes through -3 in the x-axis. That's the line x equals -3. Okay, so in terms of this region down here, well, it's below this line. So that means that y is going to be less than or equal to 4 because it's all the points that are below that line, on the line or below that line. So that would be y is less than or equal to 4. And then in terms of all these points to the right of the vertical line, well, that would be the values of x that are bigger than or equal to -3. So x is bigger than or equal to -3. So that means our inequalities would be, well, because all the heights are 4 or below, it's y is less than or equal to 4. And because all the x coordinates are bigger than or equal to -3, it'd be x is bigger than or equal to -3. So let's pick that inequality. So x is bigger than or equal to -3, but y is less than or equal to 4. So it'd be this one here. We've been asked to tick the pair, so that's it. X is bigger than or equal to -3, but y is less than or equal to 4. Okay, let's look at our next question, question number 5. Okay, let's look at our next question, question number 5. So question number 5, we've got this grid, and we've been told on the grid, label the region that satisfies all 3 of these inequalities. And we've got that x is bigger than -1 but less than 2, y is less than or equal to 8, and y is bigger than or equal to 4x, subtract 4. Okay, so let's start off with this one. X is bigger than -1 but less than 2. Now, one thing to notice here is we've got the less than and the less than symbol here, so they're going to be dashed lines. And x is bigger than -1 but less than 2. So let's start off with the first one. X is bigger than -1. So x is bigger than -1. We're going to do a vertical line passing through -1 on the x-axis because all of those points will have an x coordinate of -1. So it would look something like this. So that's the line x equals -1. Now let's draw x equals 2. So x equals 2 will be a vertical line that passes through 2 on the x-axis. So it looks something like this. So we've drawn the lines of x equals -1 and x equals 2. And we know that x is bigger than -1. So the x coordinates are going to be bigger than -1, but they're going to be less than 2. So they're going to be in the middle here somewhere. They're going to be in between those lines. So let's reject the regions to the left and to the right of those lines. So we're going to reject this region here, because here the values of x would be less than -1, and that wouldn't work. And also, let's say reject everything to the right of 2, because here all the points here would have an x coordinate, and anything to the right of this line would have an x coordinate bigger than 2. So that would not work either. Okay, so we've done that first inequality. Okay, next one, y is less than or equal to 8. So y is less than or equal to 8. So it's less than or equal to 8. So let's draw the line y equals 8. So that's going to be a horizontal line passing through 8 on the y-axis. And it's less than or equal to, so we're going to do a solid line. So it's going to be a solid line passing through 8 on the y-axis, like so. Because all the points on that line will have a y-coordinate of 8. For instance, 1, 8, 2, 8, and so on. And we're told that y is less than or equal to 8. So less than or equal to 8, we want all the points on or below that line. So let's reject above that line, like so. Okay, and then finally, we've got our last inequality here. Y is bigger than or equal to 4x minus 4. So y equals 4x minus 4. We're going to draw that line and then figure out what region we're going to accept and which one we're going to reject. So I'm going to do a little xy table here. So x and y, and 0, 1, 2. So y is equal to 4 times x subtract 4. So 4 times 0 is 0, take away 4 is minus 4. 1, 4 times 1 is equal to 4, take away 4 is 0. And 2, 4 times 2 is 8, take away 4 is 4. So we've got the points 0, negative 4, 1, 0, and 2, 4. So let's plot them. So 0, 4 would be there. 1, 0 would be there. And 2, 4 would be there. So we've got those 3 points. We now just need to draw the line passing through them. It's bigger than or equal to, so we're going to do a solid line. So we're going to draw a solid line passing through those points. So let's do that. Okay, so that's the line y equals 4x minus 4. And we want to figure out what side of the line to accept and what side of the line to reject. So I'm going to choose a point that's not on the line. I'm going to choose the origin, so the point 0, 0. So we've got the inequality y is bigger than 4x minus 4. And I'm going to choose the origin as our point. So the x-coordinate would be 0 and the y-coordinate would be 0. So y, that's 0, is bigger than or equal to 4 times x. Well, 4 times 0 is 0. Minus 4 would be minus 4. And we've got 0 is bigger than or equal to minus 4. Yes, 0 is bigger than minus 4. So that means the origin is on the side of the line that we want to accept. So we're going to reject below that line. So let's do dashes below that line, like so. And that's it. And then we have a look here. We've got our region. The question said to label the region. If you have a look here, from here down to here, across to here, and up to here, that whole region there would be the region R that we want to accept. That's the one that satisfies those inequalities. And that's it. Okay, let's look at our next question. Okay, question number 6. So question number 6, we've got these 3 inequalities. And we've been asked to label the region that satisfies all 3 of these inequalities. So we've got x is less than 3, y is bigger than negative 3, and y is less than 2x. Okay, so let's start off with the first one. X is less than 3. So x is less than 3, but we're going to draw the graph of x equals 3. So that's a vertical line that passes through 3 in the x-axis. So let's do that to begin with. And it's less than, so we're going to do a dashed line. Okay, so we've just drawn a vertical line that passes through 3 in the x-axis. So all of those points are on the line x equals 3. So that's the line x equals 3. We want the x-coordinates that are less than 3. So all the points to the left of that line would satisfy it, and all the points to the right wouldn't. So let's reject to the right of that line. So I'm just going to do little dashes here to just remind ourselves that we're rejecting anything to the right of that line. Okay, so that's the first inequality done. X is less than 3, so that's anything over this side. Y is bigger than negative 3. So let's draw the line y equals negative 3. So that'll be a horizontal line passing through negative 3 in the y-axis. And y is bigger than negative 3, so we want the points that are above the line. So let's do that. Okay, so we've drawn the graph of y equals negative 3, that horizontal line that passes through negative 3 in the y-axis. And the inequality is y is bigger than negative 3, so we're rejecting all the points below that line because all the points above the line would satisfy the inequality. Okay, and then our last inequality is y is less than 2x. So let's draw the inequality y equals 2x to begin with. So an xy table, x and y, and we'll choose 0, 1, 2. And y is equal to 2 times x. So let's multiply all of these by 2. 2 times 0 is 0, 2 times 1 is 2, and 2 times 2 is 4. So they're the points 0, 0, 1, 2, and 2, 4. So let's plot them. 0, 0, 1, 2, and 2, 4. So those points are on the line y equals 2x. The inequality is y is less than 2x, so let's do a dashed line passing through them. So let's get a ruler and pencil and do a dashed line passing through those points. Okay, so that's the line y equals 2x. Now we need to decide what side of the line we're going to accept and what side we're going to reject. So let's choose a point that's not on the line. So I'm going to choose this point here, the point 0, 2. And the inequality is y is less than 2x. And we've chosen the point 0, 2. And with that point 0, 2, the x-coordinate is 0 and the y-coordinate is 2. And again, I've chosen that point because it's not on the line. And that'll help us decide whether we're going to accept this side of the line or accept this side of the line. So here, y, that's equal to 2. Is less than 2 times x, and 2 times 0 is 0. So we've now got the 2 is less than 0. Well, that's not true. So that means that that point is on the side we're going to reject. So we're rejecting above the line, this part here, and we're going to accept below the line, this part here. Okay, so let's reject above the line. So that's anything above the line we're rejecting. It doesn't satisfy the inequality y is less than 2x. And then we're left, if we have a look here, we're left with this enclosed region here, this triangle. And inside of that right angle triangle, all the points inside of that right angle triangle would satisfy all 3 of those inequalities. And that's it. Okay, let's look at our next question. Okay, let's look at our next question, question number 7. So question number 7 says, on the grid, clearly label the region that satisfies all 3 of these inequalities below. We've got x is less than or equal to 2, y is less than or equal to 2x minus 2, and x plus y plus 2 is greater than or equal to 0. So let's start off with the first inequality. We've got x is less than or equal to 2. So I'm going to draw the line of x equals 2, and then it'll be all the points on the line or to the left of the line because x is going to be less than or equal to 2. So let's draw the line of x equals 2 to begin with. So the line x equals 2, and because it's less than or equal to, we want to draw a solid line. So I'm going to get my ruler and pencil and draw a solid line passing through 2 on the x-axis, like so. So that's the line of x equals 2. Now we want x is less than or equal to 2. So that'll be all the points on or to the left of that line, because all the points that are on the line, the x-coordinate is equal to 2, and all the points to the left of the line, the x-coordinate is less than 2. So that means we're going to reject to the right of the line. So I'm just going to do little dashes to the right of the line just to show us that we're rejecting that side. Okay, next, y is less than or equal to 2x minus 2. So I'm going to draw the graph of y equals 2x minus 2. And I'll do a little xy table, so x and y, 0, 1, 2. And to find the y coordinate, we times the x coordinate by 2 and take away 2. So 2 times 0 is 0, take away 2 will be minus 2. 2 times x, 2 times 1 is 2, take away 2 is 0. And 2 times 2 is 4, take away 2 is 2. So that'll be the point 0, negative 2, 1, 0, and 2, 2. So 0, negative 2 would be there, 1, 0 would be there, and 2, 2 would be there. So those points are in a nice straight line, nice diagonal line, and it's less than or equal to, so we're going to draw a solid line passing through those points. So let's do that. So that's the line of y equals 2x minus 2. Now we need to decide what side we're going to accept and what side we're going to reject. So let's choose a point that's not on the line. So I'm going to choose the origin. So let's go back up to the inequality, and we're choosing the origin, which is 0, 0. The x coordinate is 0 and the y coordinate is 0. So if we put those in, we get 0 is less than or equal to 2 times x, 2 times 0 is 0, take away 2. And 0 take away 2 is minus 2, so we get the 0 is less than or equal to minus 2. 0 isn't less than or equal to minus 2, so that's not right. So we're going to reject that side. So the side the origin is on, we're going to reject this side, and below the line, we're going to accept that side. So if we're rejecting above the line, let's do little dashes above the line just to show that we're rejecting that side of the line y equals 2x minus 2. Okay, so far we know it's going to be to the left of this line and below that line. So we've got this region here. And then if we look at our last inequality, x plus y plus 2 is less than or equal to 0. So x plus y plus 2 is less than or equal to 0. So I'm going to draw the graph of x plus y plus 2 is equal to 0. Now I could draw this graph as it is and do an xy table for it. I could make y the subject, and if you make y the subject you get that y is equal to minus x minus 2, and you could do an xy table for that. You could take away 2 from both sides to get x plus y is equal to negative 2 and do an xy table for that, whichever one you want to do. I'm actually just going to leave it as it is and do an xy table for this. So x and y, 0, 1, and 2. So x plus y plus 2 is equal to 0. So if x is equal to 0, we get 0 plus y plus 2 is equal to 0. So 0 plus y plus 2 is equal to 0. So on the left hand side, we've got 0 plus y plus 2 is equal to 0. Well, here y would have to be equal to negative 2, because if y is equal to negative 2, we're going to get 0 plus negative 2 is negative 2 plus 2 is 0, and that equals 0. So if x is equal to 0, y is going to have to be equal to negative 2. If x is equal to 1, we're going to get that 1 plus y plus 2 is equal to 0. So here we've got that y plus 3 is equal to 0. So y would have to be equal to negative 3 there, so negative 3. And finally, if x is equal to 2, we get 2 plus y plus 2. So 2 plus y plus 2 is equal to 0. So we get y plus 4 is equal to 0. So y would have to be equal to negative 4. So negative 4. As I mentioned, you could, if you wanted to, rearrange it and make it in the form y equals minus x minus 2. And if you times that by minus 1 and take away 2, you get negative 2. If you times that by minus 1, you get minus 1. Take away 2 is negative 3. And if you times that by minus 1, you get negative 2. Take away 2 is negative 4. So we've got those points. So let's plot them. 0, negative 2 is there. 1, -3 is there, and 2, -4 is there. So they're in that line, that diagonal line there, and it's bigger than or equal to, so we're going to do a solid line passing through those 3 points. So let's do that. And that's fantastic. We've now drawn x plus y plus 2 is equal to 0. Now we need to figure out what side we're going to accept and what side we're going to reject. So let's choose a point that's not on the line. So I'm going to choose the origin again. The origin's not on that diagonal line. So let's go back up here and we're going to choose the origin, which is the point 0, 0, with the x coordinate of 0 and the y coordinate of 0, and let's substitute them in. So 0 plus 0 plus 2 is bigger than or equal to 0. Well, 2 is bigger than or equal to 0. So yes, that would work. So that means the origin is on the side we want to accept. So we want to accept above that diagonal line. So all the points above that diagonal line would work, and the points below wouldn't. So let's reject below that diagonal line. And if we reject below the diagonal line, we're left with this region here, this triangle. So that's the region. I'm just going to label that R. So that's it. That's the region that satisfies all 3 of the inequalities we were given. Okay, let's look at our next question, question number 8. Okay, let's look at our next question, question number 8. So question number 8 says, on the grid, clearly label the region that satisfies all 3 of these inequalities. So let's start off with the first one. X is bigger than 0. So I'm going to draw the graph of x equals 0 to begin with. So x equals 0, that's the line where all the x coordinates are equal to 0. So that's going to be the y-axis. So the y-axis. And it is just where x is bigger than 0, so I'm going to do a dashed line. So I'm going to do a dashed line on top of the y-axis. So we've just drawn that vertical line that passes through 0 on the x-axis. So that's the line x equals 0. And in terms of that, it says that x is bigger than 0. So that's going to be all the points to the right of that line will satisfy the inequality. So we're going to reject to the left. So let's reject to the left of that line, and everything to the right we're going to accept. Okay, so that's the first inequality. Our next one, y is bigger than or equal to a half x. So we're going to draw the graph of y equals a half x. And if we do a little xy table, x and y, 0, 1, 2, the y coordinate is equal to half of the x coordinate. So half of 0 is 0, half of 1 is 0.5, and half of 2 is 1. So let's plot the point 0, 0, 1, 0.5, and 2, 1. And the inequality is y is bigger than or equal to, so whenever we plot them, we're going to draw a nice solid line through that line. So 0, 0 will be the origin, 1, 0.5, and 2, 1. And then because it was bigger than or equal to, we're going to get our ruler and pencil and draw a nice line through those points. So we've drawn the line of y equals a half x. Now we want to find what region to accept and which one to reject. So let's choose a point that's not on the line. And I'm going to choose the point here, 2, 0, 2, 0. So let's go up here. We're going to choose the point 2, 0. So the x coordinate is 2 and the y coordinate is 0. So y, which is 0, is bigger than or equal to half of x, and half of 2 would be 1. And we've got 0 is bigger than or equal to 1. Well, no, 0 isn't bigger than or equal to 1. So that means we're going to reject that side. So that means that we're rejecting below the line and we're accepting above the line. So this is the region that would work, and this region down here wouldn't. So let's reject below that line. Okay, then let's look at our last one. X plus 2y is less than 4. So again, let's draw the graph of x plus 2y is equal to 4. Now, unlike the others, we can't use the shortcut here because it's not just x plus y, it's x plus 2y. So I'm going to do a little xy table, x and y, 0, 1, and 2. Okay, so x plus 2y is equal to 4. So if x is equal to 0, we're going to have 0 plus 2y, well, it's just 2y, equals 4. So 2y equals 4. So it means that y is equal to 2. So that's our first point, 0, 2. Our next one, if x is equal to 1, we're going to get 1 plus 2y equals 4. So 1 plus 2y equals 4. Take 1 away from both sides, so we get that 2y is equal to 3. And then half both sides, y is equal to 1.5. So that's our next point, 1, 1.5. And if x is equal to 2, we're going to get that 2 plus 2y is equal to 4. Take 2 away from both sides, we get 2y equals 2, so that means that y equals 1. So we've got the point 0, 2, 1, 1.5, and 2, 1. So let's plot them. 0, 2, 1, 1.5, and 2, 1. So we've got these 3 points. And if we go back up to the inequality, it's just less than, so we're going to do a dashed line that passes through those points. So let's get a ruler and pencil and do a nice dashed line that passes through those points. So we've just drawn that line, which is x plus 2y equals 4. Now we want to find out what region to accept, so let's choose a point that's not on the line. And I'm going to choose the origin, the point 0, 0. So let's go back up to our inequality here, and we're going to choose the point 0, 0, so 0, 0. So x is 0 and y is 0, and let's substitute them in. So 0 plus 2 times 0 is less than 4, and we've got 0 is less than 4. Yes, 0 is less than 4, so that works. So the origin is on the side of the line that we want to accept. So we're accepting below that dashed line, but we're going to reject above it. So let's reject above it. And we've got this nice region here inside of this triangle that satisfies all three inequalities. So let's label that with an R. That region there would satisfy all three of the inequalities we were given in the question. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 9. So question number 9 says, a greengrocer sells bananas and apples, and in one day he sells less than 80 bananas, less than 90 apples, and no more than a total of 110 pieces of fruit. And we've been asked to let X be the number of bananas sold and let Y be the number of apples sold, and to show the region below that satisfies these inequalities. Okay, so let's write the inequalities down. So X is the number of bananas sold, and we're told that in that day he sells less than 80 bananas. So that means that X is going to be less than 80. And then we're told that the number of apples sold is less than 90. So Y, which is the number of apples sold, is less than 90. And then also there's no more than a total of 110 pieces of fruit sold. So that means that X plus Y is less than or equal to 110. So we have got our three inequalities. Now we just need to draw those on the grid. Okay, so let's start off by drawing X is less than 80. So that's going to be a vertical line that crosses the X-axis at 80. So let's draw that line, and it's less than 80, so it's going to be a dashed line. So let's do that. So there's 80 on the X-axis, and all the points on that vertical line will have an X coordinate of 80. So let's draw that vertical line. Okay, so I've drawn the graph of X equals 80, but the inequality was that X is less than 80. So that means that we're going to accept everything to the left of that line. So everything to the left of that line, X will be less than 80, and we're going to reject to the right. So let's shade that in. So let's just do little dashes to show that we're rejecting to the right-hand side of that vertical line. Okay, so we've done our first inequality. Our next inequality, Y is less than 90. So Y is less than 90. Let's do a horizontal line crossing the Y-axis at 90, and it's going to be less than 90, so then we're going to want below that line. So let's draw that horizontal line to begin with. So there's 80 on the y-axis, there's 100 on the y-axis, so 90 on the y-axis will be there, and we're going to draw that horizontal line. It was less than 90, so it's going to be a dashed line. So let's draw that horizontal dashed line going through 90 on the y-axis. So we've just drawn the line of Y equals 90, and it said that Y was less than 90, so it's going to be everything below that line. So let's just reject above that line, like so. Okay, so that's fantastic. We've done two of the inequalities. Okay, and then if we have a look at our last inequality, we've got X plus Y is less than or equal to 110. So we're going to draw the graph of X plus Y equals 110. And remember, whenever it's X plus Y equals a number, we can just go to that number on the Y-axis, that number on the X-axis, and join them up. Or if we do an XY table, X and Y, let's choose some values for X, such as 0, 10, and 20. And the values for Y, well, X plus Y is equal to 110. So if X is 0, Y would be 110. If X was equal to 10, Y would have to be equal to 100. And if X was equal to 20, that means that Y would have to be 90. So we've got 3 points. Let's plot them. Okay, so we've got those 3 points. Now let's draw a nice straight line through them. So let's do that. So that's fantastic. We've now just drawn the graph of X plus Y equals 110 on the grid. Now we need to find out which region we're going to accept. Are we going to accept it above that diagonal line, so this region here, or are we going to accept the region below the diagonal line? So let's choose a point that's not on the line, and I'm going to choose the origin here. So X is equal to 0 and Y is equal to 0, because the X coordinate would be 0 and the Y coordinate would be 0. So we go back up here to the inequality. We've got X plus Y is less than or equal to 110. If X is equal to 0 and Y is equal to 0, we get the 0 plus 0 is less than or equal to 110, and 0 is less than 110. So that means that that does satisfy the inequality. So we want to accept that region. So that means that the origin is on the side that we want to accept. So that means that we want to accept this region down here. So let's shade in just above that diagonal line to say that we're rejecting anything above that diagonal line, like so. And that's it. That would be our region here. So it would go across there, then down diagonally, down vertically there, across, and so on. So that's the region there. Let's just label that R. And if we go back up, the question said to show the region below that satisfies these inequalities, that X is less than 80, the Y is less than 90, and the X plus Y is less than or equal to 110. That would be this region here. And that's it. Okay, let's look at our next question, question number 10. So question number 10 says, on the grid below, shade the region that satisfies the inequalities below. And we've got 4 inequalities this time. We've got that Y is bigger than or equal to -5, Y is less than or equal to X, 5X minus 2Y is bigger than or equal to 1, and 3X plus 2Y is less than or equal to 6. And we've been asked to label that region R. Okay, so first of all, let's draw the graphs of Y equals -5, Y equals X, 5x minus 2y equals 1, and 3x plus 2y equals 6. So let's draw those on the grid below. So I'm going to start off with y equals -5. So that's a horizontal line that passes through -5 in the y-axis. So it looks something like this. So it would look something like this. And I've done a solid line. Let's just go and check it should be a solid line. Yep, that's it. And it says that y is bigger than or equal to -5. So we're going to reject below that line because we want the region above that horizontal line. Because above that horizontal line, all the y coordinates will be bigger than -5. Also remember, on the line would work as well, because on the line, all the points have got a y coordinate of -5 and it's bigger than or equal to -5. So we're rejecting below that line because none of those points would work. Okay, and then our next inequality, y is less than or equal to x. So let's draw the graph of y equals x. So if we do an xy table, xy, 0, 1, 2, y is equal to x, that'll be 0, 1, 2. So they're going to be the points 0, 0, 1, 1, 2, 2, and so on. And you should know that already. The graph of y equals x is that diagonal line, thinking to your reflections and so on. So 0, 0, 1, 1, 2, 2. And then we're going to draw a nice line through those, and it's going to be a solid line. So let's do that. Okay, so that's the line of y equals x. So now we need to decide which region we're going to accept. So let's choose a point that's not on the line. So I'm going to choose here the point 0, 1. So the point 0, 1 is not on the line. So we go back up to our inequalities. We've got 0, 1. The x coordinate is 0 and the y coordinate is 1. So we've got that y, which is 1, would be less than or equal to 0. And 1 isn't less than or equal to 0, so that's not the region we want. So we're going to have to reject that side of the line. So we're rejecting above the line and we want below the line. So let's show that. Okay, so that's two of the inequalities done. We've done the first two. Now let's look at the next one. That 5x minus 2y is bigger than or equal to 1. Well, let's draw the graph of 5x minus 2y equals 1. So x and y. And it's a calculator question, so that's quite nice. That can help you out whenever you're working these out. Okay, let's choose some values of x. So let's choose 0, 1, and 2. So we've got the 5 times x minus 2 times y equals 1. So let's start off with 0. 5 times 0 is 0. So we're just going to go over here. So we've got 0 minus 2y is equal to 1. Okay, now let's solve this. So 0 minus 2y, that'll just be minus 2y equals 1. And if we divide both sides by minus 2, we're going to get that y would be equal to minus a half. So we've got that if x is equal to 0, y is equal to minus a half, or minus 0.5. 1, 5 times x, 5 times 1 is 5, so we've got 5 minus 2y equals 1. Now let's take away 5 from both sides of that equation. So we'll get that minus 2y is equal to minus 4. And if we divide both sides by minus 2, we'll get that y is equal to 2. So y is equal to 2. And finally, if x is equal to 2, 5 times 2 is 10. So we've got 10 minus 2y this time is equal to 1. Let's take away 10 from both sides. So we're going to get that minus 2y is equal to minus 9. And then if we divide both sides by minus 2, we'll get that y is equal to 4.5. So 4.5. So we've got 3 points here, 0, minus 0.5, 1, 2, and 2, 4.5. So let's plot them. 0 minus 0.5, 0 minus 0.5 will be there. Our next point, 1, 2, so 1 across 2 up will be there. And our next one, 2, 4.5, so 2, 4.5 will be there. So we've got these 3 points here. Now let's draw a nice straight line through them, and it will be a solid line, so let's do that. Okay, so we've now got this diagonal line here, and that's the line of 5x minus 2y equals 1. Now we've got the inequality 5x minus 2y is bigger than or equal to 1. So let's choose a point that's not on that diagonal line. Origin is not quite on the diagonal line, it's to the left of it, so it's on this region here. So the point 0, 0. So let's go up to the inequality, and we're going to choose the point 0, 0. So that's the x coordinate is 0 and the y coordinate is 0. So we get that 5 times 0 is 0. Take away 2 times 0 is 0. So we get 0. So we get 0 is bigger than or equal to 1. Well, that's not true. So that's not right. So that means the origin's on the side that we're going to reject because we want the other side. So we don't want this side, we want this side. So let's reject above that diagonal line. So let's reject it. Okay, so we've rejected above that diagonal line. And then we've got our last inequality here. 3x plus 2y is less than or equal to 6. So we're going to draw the graph of 3x plus 2y equals 6. And then we can then figure out what side of the line we want to accept and which side of the line we're going to reject. So let's draw this line. So I'm going to do a little xy table. X and y, 0, 1, 2. So 3 times x, 3 times 0 is 0. Plus 2y would just be 2y, and that equals 6. And then if we divide by 2, we get y is equal to 3. So that's that point. Next, x is equal to 1. 3 times 1 is 3. And then we've got plus 2y equals 6. If we take 3 away from both sides, we get that 2y equals 3. And then if we half it, y is equal to 1.5. So that's 1.5. And then finally, we've got 2. 3 times 2 is 6. Plus 2y is equal to 6. Take 6 off both sides, so we get 2y equals 0. So that means that y is equal to 0. So we've got 3 points, 0, 3, 1, 1.5, and 2, 0. So let's plot them. Okay, so we've got those points, those 3 points there. And then if we just check, yep, it's a solid line. So let's draw a nice solid line through them. Okay, so we've now drawn that line. That's the line of 3x plus 2y equals 6. Now we want to figure out which side we're going to accept and which one we're going to reject. So let's choose a point that's not on the line. So the origin again. And I'm going to substitute in here x is equal to 0 and y is equal to 0 into here. So we're going to get 3 times 0 plus 2 times 0 is less than or equal to 6. So yes, that works. So this time we want to accept that region. So we want to accept below the line here and we want to reject above it. So let's reject above it. And that's it. So as you can see, we've got this region here. So it goes across, up diagonally, down diagonally to here, and then down diagonally a bit steeper to there. So it's that region there. And let's just label it R. And that's it. Okay, let's have a look at our next question. Okay, so let's have a look at our next question, question number 11. So question number 11 is a bit different than the other questions we've done so far, because all the other questions we've done so far, actually I think with the exception of one, we've had to draw on the inequalities on the grid and show the particular region that satisfies those inequalities. But this time we've got this region here, R. And this region R satisfies 3 inequalities. We know it's 3 inequalities because we've got these 3 lines drawn. And the question says to write down what those 3 inequalities are. Okay, so let's start by looking at each of the lines. So this line here, this horizontal line here, it's got the equation of y equals 2. It's a horizontal line that passes through the y-axis at 2. All those points on that line have got a height of 2. So if we have a look at the region, it's above that horizontal line. So it means that all the points that satisfy the inequalities will have y-coordinates that are bigger than or equal to 2 because it's on or above that line. So it's obviously not below the line. So it's going to be, our first inequality will be that y is bigger than or equal to 2. Okay, so we've dealt with that horizontal line. Now let's have a look at this vertical line here. It passes through the x-axis. It's a vertical line that passes through the x-axis at 6. So that's the line x equals 6. And it's to the left of that. So it's going to be x is less than or equal to 6. It's a solid line, so it's going to be less than or equal to. And because it's to the left, the region is to the left of that horizontal line, all the x coordinates will be less than 6 here. Or if they're on the line, equal to 6. So that's our next inequality, that x is less than or equal to 6. So let's write that. Okay, and then let's have a look at our last line. So the last line here is this diagonal line here. So we've got this diagonal line. So let's find the equation of that diagonal line. So it's going to be in the form y equals mx plus c because it's a straight line. So they will have the equation y equals mx plus c. It passes through the y-axis at the origin here at the height of 0. So it's actually just going to be in the form y equals mx. So let's find its gradient. And if we can find its gradient, we'll know its equation. So if we go across 1 unit, we go up 1. If we go across 1 unit, we go up 1. Across 1 unit, we go up 1. So the gradient is going to be 1. Or another way to do it, remember, is to make a little triangle. So I'm going to make a little triangle here. And we could do rise divided by run. We're going across 2 because we're going from 8 to 10. And we're going up from 8 to 10. So we've got a rise of 2. And 2 divided by 2 is equal to 1. So the gradient of that line is equal to 1. So that line is the line y equals 1x. But we would just write y equals x. So that's the line y equals x. Now if we have a look here, the region, as you can see here, is below that line. So what we need to do is we need to figure out here, it's a solid line, it's going to either be bigger than or equal to or less than or equal to x. And we just need to make sure we get the inequality sign the right way around. So what I'm going to do is I'm just going to choose a point that's not on the line, and I'm going to choose a point that's in the region actually that we want it to be in. So I'm going to choose this point here, the point 4, 3. So here we've got the point here 4, 3, and we know the x coordinate is 4 and the y coordinate is 3. And let's just make sure that whenever we put them here, that we're going to get the inequality sign the right way around. So we've got y, so the y is equal to 3, and we've got x, that's equal to 4. We want to make sure that we're putting it the right way around, and because 3 is less than 4, we want 3 is less than or equal to 4. So here it's going to be y is less than or equal to x. And that would work because if we had the inequality, y is less than or equal to x, if we had this point here, which is in the region that we want it to be in, which is get an x coordinate of 4 and a y coordinate of 3, if we substitute those into y is less than or equal to x, we get that 3 is less than or equal to 4, so that would work, and that would be in the region that we want, so that works. That's fantastic. So that means our next inequality was y is less than or equal to x, so y is less than or equal to x, and that's it. Okay, let's look at our next question. So question number 12, we've got another grid with some lines drawn. This time we've got some solid lines and a dashed line as well. So that dashed line, remember, that's just going to be either less than or greater than, rather than having the equals to part there. And then if we have a look at the question, it says the region labelled R, so this region satisfies 3 inequalities. Yep, we can see those 3 lines. And we've been asked to state the 3 inequalities. Okay, so let's start with that vertical line. That vertical line passes through the x-axis at 4. So the equation of that line would be x equals 4. The region is to the left of that, so every single point in that region would have an x coordinate that is less than 4. So that means the inequality for this line will be x is less than 4. So that means the inequality would be x is less than 4. And it's just less than because it's a dashed line, like so. So that means that it's going to be x is less than 4. Okay, so that's that line done. Okay, now let's have a look at this horizontal line. It passes through 4 on the y-axis, so the equation of that line is y equals 4. Now the region is above that line, so all the points in that region will have a y-coordinate that's bigger than 4. So our inequality will be y is going to be bigger than or equal to 4. And it's got the equal to part in that inequality because it's a solid line. So that means that the inequality will be y is greater than or equal to 4. Okay, so that's fantastic. We've now got two inequalities. Now let's deal with the last one. So we've got this diagonal line. So let's get its equation. So it's going to be in the form y equals mx plus c. The y-intercept is 2 here. It crosses the y-axis at 2. So that means its intercept is going to be 2. So it's going to be y equals something x plus 2. Okay, now let's just get this first bit. So let's get the gradient of the line. So I'm going to choose 2 points on the line. I'm going to choose this point, 0, 2, and this point here, 2, 6. And if we turn that into a little right angle triangle, like so, we're going to do rise over run. The run is 2, the rise is 4, and if we do 4 divided by 2, that's equal to 2. So the gradient of that diagonal line is 2. So that means this equation will be y equals 2x, and then plus 2, because it has a y-intercept of 2. Now we need to figure out, that's equal to, we need to figure out in terms of the inequality, it's going to be y and something, 2x plus 2. We need to figure out which way around the sign's going to, is it going to be greater than or equal to or less than or equal to? And I've said equal to in both cases because it's a solid line. Okay, so let's choose a point that's not on that line. I'm going to choose a point in the region that we want it to be. So I'm going to choose the point here, 3, 6. That's right there in that region, 3, 6, 3, 6, where the x-coordinate is 3 and the y-coordinate is 6. So if we put those points in, we're going to get the y, that's 6. And then we've got 2x plus 2. Well, 2 times x, 2 times 3 is 6, plus 2 is 8. So we want to make sure that we put the inequality sign so it's the right way around. So here we've got the 6 is less than 8, so it's going to be less than and equal to. So we've got y is less than or equal to 2x plus 2. And that's it, and that works. So let's just check that. If we had the inequality, y is less than or equal to 2x plus 2. So if we choose the point 3, 6, and I've chosen that point because it's on the region that we want to accept, if the x-coordinate was 3, we'd have 2 times 3 is 6, plus 2 is equal to 8, and here we've got the y-coordinate is 6, and 6 is less than or equal to 8, so yes, that would work. So that means that that's the inequality, y is less than or equal to 2x plus 2. So that's it. So the three inequalities are x is less than 4, y is bigger than or equal to 4, and then y is less than or equal to 2x plus 2. And that's it. Okay, let's have a look at our next question, question number 13. So question number 13 says, Martin has drawn the region that satisfies three inequalities. Y is less than or equal to 4, y plus 2x is greater than or equal to negative 5, and y is greater than or equal to a half x plus 1. And we've got this region here. And the question says, tick whether each of the following points satisfies all three inequalities. So we've got the first point, 2, 1. So let's plot the point 2, 1. So 2 across, 1 up. So 2 across, 1 up would be here. And the region, as you can see here, is labelled R, and it's shaded in here in lilac, light purple, whatever colour that is. So that point is not in that region. So does it satisfy all three inequalities? No, it does not. So no. Okay, B, the point 3, 3. So if we go up here, 3, 3, let's plot it. 3 across, 3 up will be there. It's in the region that satisfies all three inequalities, so yes, it does. So let's tick that one. Negative 4, 2. So let's go up. Negative 4, 2. So negative 4 will be there. 2 up will be there. No, it's not in the region, so no. Okay, the next one, negative 3, 1. So negative 3, 1 if we go up. Okay, negative 3, 1, so negative 3, 1 there. And it's on the line, so let's just double check here. We've got this line. All the inequalities have got the equal to part. So yes, this one here would satisfy all three inequalities. So yes, because it's got the less than or equal to, greater than or equal to, or greater than or equal to. If it's on the line, it would work. So that would work as well. So that one would work, yes. And then if we go down, no, there's no part A. So that's it. So the answers are no, yes, no, yes. So we've just plotted the points. The points that are in the region would work. The points that are outside the region wouldn't work. And if any of the points are on the line, like that line there, because it says less than or equal to or greater than or equal to, then they would work as well. And that's it. Okay, let's look at our next question, question number 14. So question number 14, we've got this grid and we've got this region R. And we're told the region labelled R satisfies three inequalities. And we've been asked to write down what those three inequalities are. So let's start off with this horizontal one. It's a horizontal line that passes through negative 4 in the y-axis. So the equation of the line will be y equals negative 4. The region is above that, so it's going to be y is greater than or equal to negative 4. So that's our first inequality. Y is greater than or equal to negative 4. Okay, now let's look at these diagonal lines. So let's start off with this one here. So it's going to be in the form y equals mx plus c, that diagonal line. So let's get its equation to begin with. So in terms of the plus c, it crosses the y-axis at -2, so it's going to be y equals something, subtract 2. And then in terms of the gradient of the line, let's choose 2 points. So I'm going to choose this point here and this point here. The run, we're going from 4 to 6, so the run would be 2. Then in terms of the rise, we're going up from 2 to 4, so the rise would be 2, and 2 divided by 2 is 1. So that means this equation would be y equals 1x minus 2, or just x minus 2, because we would write x rather than 1x. Okay, so that's the equation of the line, y equals x subtract 2, or y equals x minus 2. Now we want to find out what the inequality is, so we've got y and x minus 2. So let's choose a point inside the region that satisfies the inequality. So I'm going to choose this point here, the point 2, -2. So the point 2, -2. So x coordinate is 2 and the y coordinate is -2. So we'd have here y, well, that's -2. Then on the right hand side, we've got x minus 2. X is equal to 2. 2 minus 2 is 0. So in terms of this, to get the inequality sign the right way around, we're going to need to write less than or equal to, because it's a solid line, it's got the equal to part. So that means that y is less than or equal to x minus 2. So that's our next inequality. Y is less than or equal to x minus 2. And just to recap, we found the equation of the line, which was y equals x minus 2. We chose a point in the region that we're looking for here, so we chose this point here to be 2, -2. We then substituted in those values for x and x minus 2 and figured out which way around the inequality sign would have to go so that it would work. Okay, and then finally, this diagonal line here. So in terms of this diagonal line here, so I'm just going to work on the left-hand side here. So in terms of this line, let's find the equation of it. It's going to be in the form y equals mx plus c. It crosses the y-axis at 4, so it's going to be y equals something plus 4. And then in terms of the gradient of the line, let's find out the gradient of the line. So I'm going to go across and then down. So I'm going to choose this point here and this point here. The run is 2. The rise is -4, and if we do -4 divided by 2, that's -2, so minus 2x plus 4. So we've got y and minus 2x plus 4. We're going to choose a point that's inside the region, because obviously with this diagonal line, we know that this part here, this region, satisfies that inequality. So again, if we substitute in x equals 2 and y equals -2, we can figure out which way around the inequality sign would have to go. So y, that's -2. And then we've got minus 2 times x, that's minus 2 times 2, which is minus 4, plus 4 is 0. So we've got minus 2 and 0. We want the inequality sign to be the right way around for this, so we need it this way around, because here we would have minus 2 is less than or equal to 0. And I put the equal to part in there because it's a solid line again. So we've got y is less than or equal to minus 2x plus 4. And that's our inequality there. Y is less than or equal to minus 2x plus 4. And that's it there, the three inequalities. Okay, let's look at our next question, question number 15. So question number 15 says, Sanjeev has been asked to show the region that is represented by y is bigger than or equal to -2, y is less than or equal to x, and y is less than or equal to 4 minus 3x. And we've got this grid and this region here that's shown. And then we're told that Sanjeev has made a mistake and to explain this mistake. Okay, so we've got these three inequalities. Well, let's have a look. Has he drawn them correctly? Yep, and he shaded in above that. And the inequality is y is greater than or equal to -2. So yeah, that would be. It's above that line, and it's the right location for it. So yeah, it's above that line. So that seems right. Next, the next inequality. Y is less than or equal to x. So the line y equals x is that line. Yep, it goes through the point 0, 0, 1, 1, 2, 2. So he's drawn it correctly. Has he shaded in the right side? So let's choose a point that's not on the line. I'm not going to choose the origin. I'm going to choose a point that's inside his region. So let's choose this point here, the point 0, 1. So that's the point 0, 1, because it's 0 across 1 up. So it's got an x coordinate of 0 and a y coordinate of 1. The inequality was y is less than or equal to x. So here we've got y, which is 1. 1 is less than or equal to 0. Well, 1 isn't less than or equal to 0, so that's not true. So that means that that point isn't in the region that's been accepted. We should be rejecting this side. So in terms of that diagonal line here, this side should be rejected, and actually the region should be below that line. So he shaded in the wrong side of the line, y equals x. It should be below that line, not above the line. So that's not in the right region. So that's his mistake. He shaded in the wrong side of the line, y equals x. He's accepted the wrong side. So let's explain that. And that I've just explained, for y is less than or equal to x, the point 0, 1 would not satisfy that inequality because 1 is not less than or equal to 0. So Sanjeev has accepted the wrong side of y equals x. So that's it. And let's just have a look here for the last one. Y is less than or equal to 4 subtract 3x. So has he drawn the right line? So it has a y-intercept of 4. Yep. It's got a gradient of -3. So let's just check that. Across 1, down 3, across 1, down 3. Yep. So that's the right line. And has he shaded the right side? So let's choose the origin. And let's just check, has he got the right side of the line? So here we've got the point 0, 1 again. And it's not on the line, so let's use that. So y, which is 1, is less than or equal to 4 subtract 3 times 0, which is 4, and that does work. So that means that that is on the right side. So he did shade the right side of that line, but it's just that line y equals x. So the region that he should have shaded was above that line of y equals -2. It is on the left hand side of that diagonal line, and it should be below this line, so it should have been this region here, not this region here, and that's it. But as we've explained, he's shaded in the wrong side of the line, y equals x. Okay, let's have a look at our last question, question number 16. So question number 16, we've got this grid and we've got a region. And we've been asked to write down the 4 inequalities that define the shaded region. So we've got 4 inequalities here, 4 lines, and we need to write down what the inequalities would be to define this region here. Okay, so let's start off with this horizontal line here. It's a horizontal line that passes through the y-axis at -4. So y equals -4 is the equation of that line. It's above that line, so it's going to be y is greater than or equal to -4. So that one's quite straightforward, and I'll write that one down to begin with, that y is greater than or equal to -4. Okay, so we've done that horizontal line. Now let's do the vertical line. That one's going to be quite easy as well. It's a vertical line that passes through the x-axis at -1. So it's going to be x equals -1. That's the equation of that line. And it's to the left of it, so it's less than or equal to -1. So it's going to be that x is less than or equal to -1 because it's to the left of that vertical line. So it's everything to the left of it, so it's going to be less than or equal to -1. And because it's a solid line, that's why it's equal to. Okay, so we've done those two lines, the horizontal one and the vertical one. So now let's have a look at these two diagonal lines, this one and this one. So I'm going to start off with this diagonal line here. So its equation will be in the form y equals mx plus c, so mx plus c. In terms of finding the equation of this diagonal line here, it crosses the y-axis at 4, so it's going to be in the form y equals something plus 4. In terms of the mx, let's find the gradient of this line. So I'm going to choose a point here. I'm going to choose this point here. And in terms of the rise and the run is 4. We're going 4 across there. And the rise is -1. And if we do -1 divided by 4, that's -1/4. So -1/4 x plus 4. So that's the equation of that line. Y is equal to -1/4 x plus 4. Now let's choose a point that's not on the line, and I like to choose one that's inside the region, so I'm going to choose this point here, -2, 0, so -2, 0. The x coordinate is -2 and the y coordinate is 0. So we want to write down an inequality, so we want to have y, and then we've got -1/4 x plus 4, and we want to figure out which way around this inequality sign will go here. And just to also mention, it's a solid line, so it's going to be less than or equal to or greater than or equal to. So here y, that's 0, so 0. And here -1/4 of x, well, -1/4 of -2. Well, we've got a negative and a negative, so that's going to be a positive. And 1/4 times 2 will be 1/2, so that's going to be 1/2. And then plus 4 would be equal to 4.5, so 4.5. So that's equal to 4.5. So that means that we want the inequality symbol to go that way around. So it's going to be that y is less than or equal to -1/4 x plus 4. So let's write that down. The y is less than or equal to -1/4 x plus 4. Okay, so we've got 3 of the inequalities. Now we just need to deal with this diagonal line here. So we've got this diagonal line here, and we need to find the equation of that line and then figure out what the inequality would be. So we know it's a straight line, so it's going to be in the form y equals mx plus c. Let's find out the y-intercept and the gradient. So I'm going to start this time with the gradient because the y-intercept's not on the grid. So let's figure out what the gradient will be first. So I'm going to choose 2 points on the line. I'm going to choose this point here, and I'm going to choose this point here. And in terms of the gradient, we're going across 1 and up 3. So that means that the rise is equal to 3 and the run is 1. 3 divided by 1 is 3. So it's going to be y equals 3x. And then now let's figure out what the y-intercepts would be. Now, there's a few different ways we could find the y-intercept here. The approach that I'm going to use is I'm just going to use common sense. The gradient's 3, so that means that every time we go across 1, we're going up 3. So across 1, up 3, we've now got a height of 3. Across 1, up 3, we've now got a height of 6. Across 1, up 3, we've now got a height of 9. And one more, across 1 and up 3, we've now got a height of 12. So that means it's going to cross the y-axis at 12. And so it's going to be y equals 3x plus 12. So that's the equation of that line. Now, we know it's going to be an inequality, and we want to find out which way around that inequality sign will go. It's a solid line, so it's either going to be greater than or equal to or less than or equal to. And we're going to use this point here. We've used it already. We've got the point -2, 0. It's in the region that we want it to satisfy, so we want to make sure that when we put this point into this inequality, that the inequality symbol's the right way around. So x is -2 and y 0, so we're going to have the 0. 3 times -2 is -6, plus 12 is 6. So in terms of the inequality symbol, we want it around this way here. We want it to be that y is less than or equal to 3x plus 12. So y is less than or equal to 3x plus 12. And that's it. And so that means our three inequalities are y is greater than or equal to -4, x is less than or equal to -1, y is less than or equal to -1/4 x plus 4, and y is less than or equal to 3x plus 12. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on Graphical Inequalities. I really hope you found this video useful, and if you have found it useful, please like and please subscribe to the YouTube channel. If you need any extra help on graphical inequalities, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 180, 181 and 182, there's dedicated video tutorials there on different aspects of graphical inequalities. Alternatively, you can scan this QR code. But in this video, we'll focus on the video solutions to the practice questions. Again, I really hope you found this video useful, and if you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.